For decades, the idea of intelligent machines traveling through space seemed like the stuff of science fiction. Movies like 2001: A Space Odyssey gave us a glimpse into what this might look like, where AI systems like HAL 9000 assisted astronauts, or in some cases, became a threat. The myth of rogue AI was born, creating a sense of fear about letting machines think for themselves. But the reality of AI in space exploration today is far from these dystopian tales. The origins of AI in space exploration trace back to simple systems used in early missions. In 1976, NASA's Viking landers were equipped with rudimentary programs to control their instruments on Mars, though these early systems were far from intelligent. They relied on step-by-step instructions pre-programmed by engineers on Earth, but the limitations were clear. When something unexpected happened, the spacecraft had to wait for new commands, sometimes delaying responses by hours or even days. This delay was manageable for early missions but became impractical as we ventured further into space. Enter AI. In the late 1990s, advancements in machine learning and robotics began to revolutionize space technology. NASA's 1997 Mars Pathfinder mission was one of the first to incorporate a semi-autonomous rover, Sojourner, which could make simple decisions about where to drive. However, it wasn't until the 2000s that we saw a real leap in autonomy with the Mars exploration rovers, Spirit and Opportunity. These rovers were equipped with AI that allowed them to navigate the Martian surface, avoid obstacles, and even choose scientifically interesting targets for study, without needing direct control from Earth. This was a groundbreaking development, as the communication delay between Earth and Mars can be as long as 24 minutes. But even with these advancements, AI in space was still in its infancy. The real revolution came in the 2010s with the Curiosity rover, which carried more sophisticated AI systems, including autonomous navigation software. Curiosity could analyze its surroundings and make decisions in real time, allowing it to cover more ground and collect more data than any previous mission. This marked a turning point in space exploration, where AI wasn't just a tool, but a partner in discovery. Fast forward to today, and AI is becoming indispensable in missions like NASA's Perseverance rover, which landed on Mars in 2021. Perseverance uses AI not only to navigate, but also to conduct scientific experiments, analyze soil samples, and even search for signs of ancient life on Mars. Its AI-driven Ingenuity helicopter has flown in the thin Martian atmosphere, taking aerial surveys and scouting locations that would be difficult for a rover to reach. But what about the myths surrounding AI? Some fear that as AI becomes more advanced, it could develop its own goals, leading to scenarios where machines act against human interests, like in the famous AI overlord trope. While this is a persistent fear in pop culture, scientists are quick to point out that AI systems used in space are carefully controlled and highly specialized. They are not sentient, and they don't have the ability to go rogue, as Hollywood often suggests. The real risks involve technical failures or miscommunication between humans and machines, not malevolent AI. As AI continues to evolve, the line between science fiction and reality will blur even further. The rise of AI in space is not just about making our missions more efficient. It's about expanding the horizons of what's possible in the universe. Imagine this: a spacecraft deep in the solar system, traveling through the rings of Saturn or navigating the treacherous environment of a distant moon. The spacecraft doesn't wait for instructions from Earth, which could take hours to arrive. Instead, it uses AI to assess its surroundings, make decisions, and chart its own course. This isn't the distant future. It's happening now, and it represents a major leap in how we explore space. Autonomous spacecraft represent one of the most exciting developments in AI and space exploration. Today's space missions are no longer limited by the lag time of human communication. Autonomous spacecraft equipped with AI can perform complex tasks on their own, saving time and resources. One recent example is the OSIRIS-REx mission, which successfully collected samples from the asteroid Bennu. During its mission, the spacecraft used AI to autonomously navigate around the asteroid, identify potential sampling sites, and safely land on its surface. This kind of precision would be impossible to achieve with human control alone, especially with the communication delays involved. The European Space Agency's ESA JUICE mission, Jupiter Icy Moons Explorer, is another exciting project that showcases the power of AI in space exploration. Scheduled to launch in the 2020s, JUICE will study the icy moons of Jupiter, Ganymede, Europa, and Callisto. These moons are some of the most promising candidates for finding extraterrestrial life in our solar system, and JUICE will rely on AI to navigate through Jupiter's intense radiation belts, gather data, and avoid potential hazards. The spacecraft will need to make complex decisions about where to focus its observations, all while operating far beyond the reach of real-time human control. But how does this autonomy work? Spacecraft like JUICE are equipped with machine learning algorithms that allow them to process vast amounts of data in real time. These algorithms can detect patterns, identify potential hazards, and optimize the spacecraft's path to maximize the scientific return. In some cases, these systems can even make predictions about future events, such as incoming solar storms or the behavior of celestial bodies, allowing the spacecraft to adapt on the fly. Of course, the idea of autonomous spacecraft also sparks some myths and concerns. One common misconception is that AI-driven spacecraft might decide to explore areas that humans hadn't intended, or worse, ignore human commands. While autonomous spacecraft do have the ability to make decisions, these decisions are strictly within the parameters set by mission planners. The AI systems are designed to optimize the mission goals, not deviate from them. There's also the concern that autonomous spacecraft could malfunction and get lost in space, which is a genuine risk. Space is an incredibly harsh environment, and even the most sophisticated AI systems are vulnerable to damage from cosmic radiation, mechanical failures, or unforeseen obstacles. However, AI has actually proven to be more resilient than traditional systems in some cases, as it can detect and correct errors more quickly. As AI continues to advance, we may one day see fully autonomous missions to distant stars and galaxies. These spacecraft would be capable of exploring unknown regions of the universe, gathering data, and even making discoveries that humans hadn't anticipated. Autonomous exploration could open the door to a new era of space travel, one where humans aren't just passengers on the journey, they're the architects of intelligent systems that venture where no human has gone before. As humans push further into space, the challenges of long-term space travel become more daunting. From radiation exposure to psychological isolation, astronauts face a host of challenges that could make future missions to Mars or beyond incredibly difficult. That's where AI comes in, not just as a tool, but as an essential companion to help astronauts survive and thrive in space. One of the most exciting developments in AI-assisted space exploration is the emergence of AI-powered robots and virtual assistants. These systems are designed to work alongside astronauts, helping them with everything from conducting experiments to managing life support systems. One early example of this is CMON, Crew Interactive Mobile Companion, an AI assistant developed by IBM and tested aboard the International Space Station, ISS. CMON is essentially a floating brain, a voice-controlled robot that can assist astronauts by pulling up procedures, answering questions, and even offering emotional support. It's equipped with facial recognition and natural language processing, which allows it to interact with astronauts in a way that feels almost human. CMON is a glimpse into the future of human-AI collaboration in space. On future missions to Mars, AI assistance will be even more critical. Mars is a hostile environment with harsh radiation, extreme temperatures, and a thin atmosphere. Human crews on Mars will need to rely on AI to help monitor their health, manage resources, and conduct scientific research. These AI systems will act as both co-workers and companions, helping astronauts perform their duties more efficiently while also providing psychological support during the long isolation. One of the myths about AI assistants is that they might replace human astronauts altogether. Some skeptics argue that with advanced AI, there might be no need to send humans to space at all. However, most experts agree that AI will never fully replace humans in space exploration. While AI can perform many tasks more efficiently than humans, there are still areas where human intuition and creativity are irreplaceable. In fact, AI is more likely to enhance human space exploration by taking on the dangerous, monotonous tasks that would otherwise put astronauts at risk. Another concern is that AI assistants might become too emotionally detached, leading to issues of trust or reliance. While AI can analyze data and perform calculations, it lacks the emotional intelligence that humans naturally have. Some experts worry that over-reliance on AI might cause astronauts to lose their critical thinking skills or become too dependent on machines for decision-making. To counter this, AI developers are working on creating systems that can recognize and respond to human emotions, offering support in ways that go beyond mere data analysis. As we look ahead to future missions, AI assistants will likely become an integral part of space exploration. They will help astronauts with tasks ranging from routine maintenance to medical emergencies, acting as both a safety net and a source of support. Whether we're building bases on the moon or traveling to distant planets, AI will be there every step of the way, making space exploration safer, more efficient, and more achievable than ever before. AI's influence isn't just limited to robotic missions and astronaut support. It's also transforming the way we study the universe itself. AI is being used to analyze vast amounts of data from telescopes, satellites, and space probes, uncovering new insights about distant planets, stars, and galaxies. In many ways, AI is becoming the eyes and ears of space scientists, processing information faster and more accurately than ever before. One of the most exciting developments in this area is the use of AI in the search for extraterrestrial life. Scientists are using machine learning algorithms to analyze data from missions like the Kepler Space Telescope, which has discovered thousands of exoplanets. These AI systems can sift through massive amounts of data to identify planets that might have conditions suitable for life, such as Earth-like atmospheres or the presence of water. In fact, AI has already helped identify several exoplanets that were missed by human researchers, proving its value as a tool for discovery. AI is also playing a crucial role in the study of black holes, dark matter, and the origins of the universe. One of the most famous examples is the Event Horizon Telescope, which captured the first ever image of a black hole in 2019. This groundbreaking achievement was made possible in part by AI, which processed and stitched together data from multiple telescopes around the world. Without AI, this image, one of the most important scientific discoveries of the 21st century, might never have been captured. Another area where AI is making a big impact is in space weather prediction. Solar storms and cosmic radiation pose significant risks to both astronauts and satellites, and predicting these events is crucial for space exploration. AI systems are being used to analyze data from the sun and make predictions about solar activity, helping space agencies prepare for potential hazards. These systems can even provide early warnings about incoming solar flares, giving astronauts time to take shelter and protect their equipment. But while AI has made incredible advancements in space science, there are still many myths and misconceptions about its capabilities. One persistent myth is that AI will one day solve all the mysteries of the universe, leaving little for humans to discover. This myth stems from the belief that AI is infallible and can process data in ways that humans cannot. However, AI is only as good as the data it's given, and there are still many areas of space science that require human insight and creativity. Another myth is that AI will replace human scientists in the field of space research. While AI can analyze data faster than humans, it lacks the ability to interpret that data in the context of broader scientific theories. Human scientists are still essential for making sense of the discoveries AI uncovers and for asking the big questions that drive space exploration forward. Looking to the future, AI will continue to expand the boundaries of what we know about the universe. It will help us explore new frontiers, make sense of the vast amounts of data we collect, and uncover the secrets of distant worlds. Whether we're searching for life beyond Earth or unlocking the mysteries of black holes, AI will be an essential tool in our quest to understand the cosmos. As we enter a new era of space exploration, AI will play an increasingly vital role in shaping our journey to the stars. From autonomous spacecraft that can explore distant moons to AI assistants that help astronauts survive in harsh environments, the possibilities are endless. While myths and fears about rogue AI persist, the reality is that AI is a powerful tool for discovery, not a threat. It is not here to replace humans, but to empower them, allowing us to explore deeper into space than ever before. As AI continues to evolve, we can expect it to unlock new frontiers in space science, helping us answer some of the biggest questions about the universe. Will we find life on other planets? Will we uncover the true nature of dark matter and dark energy? AI won't give us all the answers, but it will be a key partner in our quest for knowledge. The future of space exploration is bright, and AI will be at the heart of it, guiding us as we venture beyond the known and into the infinite mysteries of the cosmos.